Alright, so let's finish up the podcast. First, we have our PowerPoint to go over. Let's do that. Alright, our CS project. So obviously CS project. Now, played. What does the game do? How is it played? Basically, it's just like any other Snake game, except you can actually click on the title menu this time. Use the left click on the mouse, explained in the last video. Demonstration. Yeah, let's do that. At the end of part 1. Let's do that. But for some reason I have to, let's go back into here. If for some reason, let me hit Windows tab now. I have to hit Alt tab to actually get in my program and test it out. That's what it says in the requirements. So we're gonna do that. Let's test out the game. Doink, doink, and kablamo. It's all good. Alright, let's get out. Now, let's go back to the PowerPoint. Now, functions. We have, these are just some of the a couple of functions I pulled out of my program earlier. My play button, collision, and play button is just for initializing the actual play button. Then I have the void draw, play button B, collision, and play button. This actually makes it so it draws the play button so you can actually collide into it. And void apple, and this makes it so you can just initialize it. And these, let's go into the next one. Parameters, move snake up, snake and snake, body and body, and throughout each function I pass in the same thing. The only difference between each is they say right, left, down, and up. So they're functions with parameters that just make the snake move up, down, right, left, or right. They have the same value in all of them because I'm using a public value in my struct that I explained earlier in the last video, part 1. So relational operators, I used, I just pulled up 3. So for int I equals 1, I greater than score dot size I plus plus. So I use a greater than. If I is less than, so I use the less than sign. My bad, not a greater. And if done equals true. So here I used the equal. Else if snake.x plus snake.bx. And here I used a greater than. Now this was for the actual collision itself. This is for the function if it's not done. And this is for a loop to iterate the size as it goes on. These are some primitive data types. Int width equals 1920, double height equals 1080. I just pulled out some of my global variables that are used to express each different kind of data type that we had to use. Well, except for float, we didn't have to use floats. But besides that, we had to use all these other ones. Special features, once again I used Allegro, and I'm pretty sure I explained everything that was special about it in part 1. Move my snake easier and make the game much smoother. Bugs, I didn't have any bugs. As you can see, the program ran, but I did not finish my program all the way as explained and as you saw. Citations, I didn't use any, I coded this all myself, but I did get a lot of help from Mike Geig at his YouTube channel right here. So if you want to learn how to code in Allegro and do a lot of other neat coding and easier ways to code, go check him out. Then conclusion, difficulty level, this was very hard. Fun, it was pretty dang fun. Even for just coding, it was fun. Your evaluation of your final project, I give it an actual 8. I would give it a 10, but as you can see, it's not done, so maybe later I could change it to a 10. What you learned, I learned a lot. I learned how to do Allegros, what it was about. Delays, you can actually do delays in C++. That's how I was trying to get my body to work. Um, just a lot. How to actually use buttons on the keyboard to make things work in the function. How to input pictures and any questions. So now that we've gone through that, let's actually go through the code alongside the uh, the actual product, the actual project, so we can go through each of these one at a time. So I use at least create and use at least the following primitive data types in double bool char. So once again, I showed it all the way up here. I have all of them. Bool, int, double, and then here I have a char. Relational operators equals equals not equals greater than or equal to less than or equal to. Here is let me pull some up. An equal, that's 1, so we need 3. That's 1. Not equal, here's 2. And one more. Greater than or less than, so I just pulled up 4 there. Logical operators and or not, use 2. So right off the bat, we can see I have a and right there, and I have a not right there for not done for my function. Use or more, one or more if else statements. I actually used a lot of these. One, just in this one if statement. 1, 2, 3, 4, 5. 5 right there, kablam. And if you want to see a switch statement, here's another. Inside an else if, so that's already what, 7. Yeah, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, it's a lot. One or more while, do while, for loops. Once again, I use a lot of those. Here's already one while loop right there. Here's a for loop right there. I don't believe I have a do while. I did when I was messing around with some stuff, but then I got rid of it because I didn't need it. At least 5 functions. One must contain at least 2 parameters. One must have a default value. Here you can see I have way more than 5 parameters. All of these bad boys parameters, and you can see here we already not parameters, but all those prototypes, and the prototype is basically just declaring the function, so I don't have to actually go into the function themselves. It's already right here. So here you can already see I have 2 parameters, and one containing a default value. A default value is just setting something so it always equals that value. And as you can see, I have a default value here with char y. And if you go to the actual function, char y equals y. So there's my default value. And then here's my int main. Include parameter at least one passed by value and at least one passed by reference. Once again, we could pull up another parameter. Another prototype. Here's Apple B collisions. There's a parameter. We go down to the function. What was it again? Apples B. We go down to the function. Apples B. And what does it say? Pass by value and at least one pass by reference. Apples, and I bring in .x, .y from apples. So there you go. Declare, initialize, iterate, and modify arrays / vectors. Now where is it? For these two right here, declare, initialize, modify array, transverse, and access an array, I used, let's go all the way up here. I used this little section right here. Not this, but this right here. I use an array, all scores, to actually put in the score of the past game. So if you lose, it writes the score to a value, and it pulls it out. It pulls out the highest score, as you saw in the last video, how at the highest score and at attempt what. And so that was for my pointer. The attempt was my pointer because it pointed out how many attempts I did and where it was. And then arrays or vectors. It transversed, so it goes through it and finds the highest index. And now let's go on to 11, comments explaining logical operators. You can see I have a ton of comments everywhere. 12, animation or graphical interface. You already saw that, but I could pull it out. Here's one right here, body.png, snakebody.png. Meaningful variable names. As you can see, all my variables are in camel case. Here, function. Here, it doesn't have to be camel case because this is technically not one variable. It is multiple put together, so no, that is not one variable. Get score, highest index, placeholder, those are more camel case variable names. Documentation, I actually did not do. I was just too lazy. Didn't want to. And yeah, that's it. That's all I have for this video. I hope you liked my project. I put a lot of work into it, and so I have to say, peace.